3.
Good morning students. My name is S. Sudeshna. Today we will discuss about lasers. Lasers. First we define lasers before we discuss about coherence. We know that coherence between two sources of light. The two coherent sources of light, when they are in same phase or constant phase difference. We know that light will be come from different radiations is the sum of total radiations of light from billions of atoms or molecules in a source. Atoms and molecules in source. We know that the light from different radiations and different angles, that is phase. That is phase. Phase is different from different times. Why the phase is different from different times? Because the light will be radiated in different radiations, in different angles. The light will be different in different radiations and different angles. At that time, the phase will be changes at different times. Depending on the phase, we can define the phase radiation. There is a total phase difference between the different types of angles. Now the lasers, there are some different types of sources of atoms of different molecules in different radiations. They are in polarization, that is the coherent of source. Different radiations occurring different atoms in polarization is called coherent of source. In recent years, some coherent sources are developed or highly coherent. In recent years, some coherent sources are developed in highly coherent, that is called as lasers. So first we know about the laser. First we discuss about the coherence. And then what is the laser? Full form of laser. Laser is a laser means light amplification by stimulated emission of radiation. This is the full form of the laser, light amplification by stimulated emission of radiation. In this laser form, we can define amplification, stimulated emission and radiation. In 19, the laser gives high monochromaticity, high directionality beam of collimated, high directionality beam of collimated laser. This helium neon laser emits visible light, that is white light. You can see the white light from bulbs and tube lights also. That is emits visible light which have wavelength 624.3 nanometers. It is also emit the radiation in infrared region, which is 1150 nanometers. This is the introduction of the lasers. Next, properties of lasers. There are four properties of lasers. First one is high monochromaticity. Second one is high directionality. Next one is high coherence. And fourth one is the high intensity. These are the four properties of the laser. First one is high monochromaticity. What is meant by monochromaticity? Monochromaticity means the laser gives the radiation in a narrow bandwidth. Narrow bandwidth is called monochromaticity. Or monochromaticity, or it is a single wavelength. It is a single beam of light. It is a single beam of light. Next one, high directionality. What is meant by directionality? Directionality means the light gives not normally ordinary light gives in different directionalities. This is the different directionalities. But the laser light gives in one way of the directionality. This is called as directionality. Only single direction will be given or emitted. Is called directionality. What is mean by high coherence? Already we discussed about coherence. Coherence means same phase or constant phase difference. What is mean by same phase and constant? Suppose there are two waves are emitted from the light radiation. There are two waves are emitted from the light. They are in same phase. It is called coherence. In the same, this is the same phase. It is called phase. In the same phase or occur at that time, the coherence will be occurred. Next, high intensity. Intensity means it is a maximum strength. The emitted light radiation will be high intense or dark. That is called as intensity. These are the properties of the lasers. What is the difference between ordinary light and the laser light? Why we don't use in industries etc. Why don't we use ordinary light? The difference between ordinary light and laser light does not emit monochromatic. The ordinary light does not emit monochromatic. Laser light have emit high monochromatic. lasers. After we developed the laser, some scientists have discovered different types of lasers. There are 5 types of lasers. Types of lasers. First one is solid laser, gas laser. Next one is liquid laser, and next one is dye laser and semiconductor lasers. These types of lasers are used to different purposes for our future generations and present generation of the technology. Solid lasers are called as, for examples, ruby laser is the solid laser, helium ion laser is the gas laser, and liquid laser is the SiO2 is the liquid laser, and dye laser is the rhodium laser, and semiconductor laser is the gallium arsenic lasers. These are the examples of the solid laser, gas laser, and different types of lasers. There are some more examples, but mainly we are using these types of lasers in different purposes. So that's why we are explaining about ruby laser, helium ion laser, and other lasers. First, basic principle of the laser. Basic principle of laser. What is the basic principle of laser? The basic principle of the laser is the light process is amplification by the process of energy transmission phenomena in its active medium. Energy transmission of phenomenon. Energy transmission phenomena of atoms or molecules in active medium. This is called as the basic principle of laser. First of all, we define the laser. Some terms are explaining about the laser. They are radiation, absorption of radiation, absorption of radiation. Next one, spontaneous emission. And next one is the stimulated emission, or this is also called as induced emission. These 3 types of radiations are very important for the laser process. These are the main principles of the laser process. First, we discuss about absorption of radiation. What is mean by absorption? Absorption is nothing but to absorb the energy or to absorb the molecules, etc. To absorb. First, absorption of radiation. We know that electrons revolve around the nucleus in a discrete orbits. In discrete orbits, we have energy levels. In discrete orbit, we have different number of energy levels. Suppose this is the nucleus, the atoms will revolve around the nucleus in different discrete orbits. The discrete orbits are also called as energy levels. In the basis of the energy levels, we discuss about absorption of radiation. Let us consider 2 energy levels. Let us consider 2 energy levels, 1 and 2. Let us consider 2 energy levels, 1 and 2. They have their energies E1 and E2. These are the state, and then after it receives the energy, it will jump to the lowest state to excited state. This is called as excited state. This process is known as absorption. This process is known as absorption. In this absorption, we can define the frequency. How we can define the frequency? We have two energy levels. The difference between two energy levels is called as light radiation, H mu. We can define the frequency. This in the terms of H is the Planck's constant, mu is the frequency. So we can define the frequency. Mu equal to E2 minus E1 by H. This is known as stimulated absorption or absorption of radiation. We know that all the atoms will be from ground state to lowest state, the excited state will be occur. In this excited state, some lifetime is occurs. What is the lifetime? The lifetime means the atom will be present in that state for some time. The lifetime of the excited state atoms is 10 to the minus 8 seconds for hydrogen atom. 10 to the minus 8 seconds for the hydrogen atom. This is called as lifetime of the excited state or any state. This is the lifetime of the atom in an excited state of 10 to the minus 8 seconds for hydrogen atom. After that, this is known as that state is also known as metastate or metastable state. The state is also known as metastate or metastable state. This is known as absorption of radiation. ఎప్పుడైతే ఆటం అనేది లోయర్ స్టేట్ నుంచి గ్రౌండ్ స్టేట్ నుంచి హైయర్ స్టేట్ కి ఎగ్జైటెడ్ అవుతుందో దాన్ని అబ్జార్ప్షన్ ఆఫ్ రేడియేషన్ అంటారు. విత్ రిసీవింగ్ ద అమౌంట్ ఆఫ్ ఎనర్జీ దాన్ని అబ్జార్ప్షన్ ఆఫ్ రేడియేషన్ అంటారు. నెక్స్ట్ వన్ ఇస్ ద spontaneous emission. Spontaneous what is mean by emission? First of all, we know that absorption, and next one emission. Emission means to emit the energy. ఎప్పుడైతే ఎనర్జీని అబ్జర్వ్ చేసుకుంటామో అప్పుడు ఆ ఎనర్జీని ఎమిట్ చేయాలి కదా, సో దాన్ని ఎమిషన్ అంటాం. In that emission process there are two types. One is the spontaneous emission and the one is the stimulated emission. Now we discuss spontaneous emission. What is the spontaneous emission? Spontaneity means to work in frequent time. That means spontaneous emission. Let us here also consider two energy levels. One and two. This is the E1. This is the E2. Already the atom will be in excited state. In that excited state, the second in the lifetime of 10 to minus 8 seconds, within the lifetime of 10 to minus 8 seconds, the excited state atom will be jumped to lowest state, that is called as ground state. In the period of seconds, the excited state atom will be jumped to ground state. It is called as spontaneous emission. This is called spontaneous emission. ఎప్పుడైతే ఎగ్జైటెడ్ స్టేట్ లో ఉన్న ఆటం అనేది వితిన్ సెకండ్స్ లో గ్రౌండ్ స్టేట్ ఎప్పుడైతే రీచ్ అవుతుందో విత్ ద ఎమిటింగ్ ఆఫ్ ఫోటాన్, ఆ గ్రౌండ్ స్టేట్ కి వచ్చేటప్పుడు అది ఎమిటింగ్ చేస్తుంది. దేని ఎమిటింగ్ చేస్తుంది? ఎప్పుడైతే ఏ ఎనర్జీని అయితే తీసుకుంటుందో ఆ ఎనర్జీని అది ఎమిటింగ్ చేస్తుంది. దాన్నే స్పాంటేనియస్ ఎమిషన్ అంటారు. దిస్ ఇస్ కాల్డ్ as spontaneous emission. Next one is stimulated emission or induced emission. Stimulated emission or induced emission. What is stimulated emission? Here also to consider two energy levels. This is the E2, this is the E1. The atom will be excited state, same as a spontaneous emission. The atom will be radiation h mu to give the energy of the radiation h mu, but still the atom is in excited state. The energy will be grabbed to the excited state atom, and then after within the lifetime of span, within the lifetime 10 power minus 8 seconds, to excited state atom will be jumped back to the ground state with the emitting of two photons. With the emitting of two photons. Why the emitting of two photons? Already the excited state atom having energy h mu, and then after we will give some external amount of energy, that is the h mu. That energy also released from the stimulated emission, that is 2 times the energy will be emitted. This is called as induced emission. Why we called also induced emission means to induce the amount of energy from the excited atom. అంటే మనం ఆల్రెడీ ఒక ఎనర్జీ ఉన్న ఆటంకి మనం ఇంకొంచెం ఎనర్జీ ఇస్తున్నాం. అలా ఎనర్జీ ఇచ్చినప్పుడు ఏమవుతుంది అంటే ఆ ఎనర్జీ అనేది ఇంకొంచెం ఉన్న ఎక్కువ హై ఫ్రీక్వెన్సీ ఉన్న ఆటంని రిలీజ్ చేస్తుంది. దట్ ఈస్ కాల్డ్ యాజ్ స్టిమ్యులేటెడ్ ఎమిషన్ ఆర్ ఇండ్యూస్డ్ ఎమిషన్. Difference between spontaneous emission and stimulated emission. In the spontaneous emission, within seconds, the atom will be back. Back means it will back to ground state. And stimulated emission, to give the external amount, to give the external amount of energy, and then after the atom will be back. This is the stimulated emission. In this emission, low bandwidth, that is bandwidth means amount of